Alright, question 7, some more trigonometry. Let's get into it. So we have a diagram here. Let's just read the instructions. It shows a solar panel ABCD, which is affixed to a flat piece of concrete slab, EFCD. And if ABCD and EFCD are two identical rhombuses, so both of these are a rhombus and they're identical. Okay, K is a point on DC such that DK equals KC. So DK and KC are equal in length. And yes, and AK and DC are perpendicular. AK and DC are perpendicular. So that's a 90-degree angle. AF and KF are drawn. So AF is drawn there and KF is drawn here. ADC and CDE are both 60 as shown. That part is 60 and this angle is 60, and AD is x units. So AD is x units, and since it's a rhombus we know that all of these sides are x units long. Okay, question 7.1. 7.1. Alright, determine AK in terms of x. So that's AK. So for this one I think we'd use this triangle. We'd use triangle DAK. Here we know that's x. We know this is 60 degrees. So how do we find this missing side? Well, we can use the sine function. So sin of 60 equals opposite, which is AK, over hypotenuse, which is x. Multiply both sides by x and we get x sin 60 equals AK. So that's fine, but we know what sin 60 is as well. We know that sin 60 is square root 3 over 2. So that is equal to AK. There we go, that's the answer to 7.1. 7.2. 7.2, determine the size of angle KCF. So KCF. Let's draw that one over here. KCF. K and C and F. Right, so they ask what is this angle? Now in the rhombus we know that this line is parallel to this line and these two lines are also parallel. So we know this angle here, angle D, and angle C there must be co-interior, so together they must make 180. So all we need to write is 180 minus the 60 that we know is equal to the 120 for angle C. That's it, 120, 1 mark. Now let's just fill this in here. So that's 120. Now let's get to question 7.3, and now this is a bit of an ugly one, and we can see it counts 7 marks, so it's fair for them to have a sort of ugly question here. So they say it is further given that AKF, so this angle here, that angle, that is angle Y. Okay, is Y. Determine the area of this triangle. So now we have to find the area of triangle AKF. So let's just draw it in so we can see which one we're talking about. So triangle AKF, that's the one. Okay, so far we know this distance is x root 3 over 2, right? We found that in question 7.1. We know this is angle Y, so we still need to find this side, because the formula for the area of a triangle is area equals half times A times B times sine of C. So that just says half times side times sine of the angle in between them. So if we have this side, then we can say half times this side times sin of Y, which is the angle between them. So how do we find this side? Well, we can look back to question 7.2 and work that out there. So in here we know the angle here is 120. We know that it's a rhombus, so these two parts are equal, DK and KC, so both of them must be half of x, right? Half of x. And we know this one must be a full x. Okay, so how do we find this length then? Well, we use the cosine rule. So we want to say KF squared, so KF squared is equal to x over 2 squared plus x squared minus 2 times x over 2 times x times cos of that angle, which is 120. Alright, so let's multiply this out. This gives us x squared over 4 plus x squared. And this, the 2's will cancel, and then we're left with x times x is x squared. And cos 120, that's negative a half. Okay, so if I'm just going to put everything over the multiple of, well, let's first just multiply that half in. I'm doing everything step by step here. And then this will give us plus half x squared. So x squared over 2. Okay, let's find a common denominator. So we'll make that a 4. This will be x squared. This one needs another 4, so 4x squared. And this one needs another 2, 2x squared. So our final answer for this part is 1 plus 4 plus 2 is 7x squared over 4. So that is this length, 7x squared over 4. And let's write it in there as well. 7x squared over 4. Well, that would have been, but what is the problem here? The problem is we still need to take the square root, right? We still need to take the square root. So at the moment this is still kf squared. So we just need to take the square root to get kf. So kf will be root 7, and just an x, and the square root of 4 is 2. So that one, that is our length for kf. So let's put that in. So that's x root 7 over 2. And now we can work out the area. So area equals half times the one length, which is x root 3 over 2. And the other length is x root 7 over 2. X root 7 over 2. Sorry, I'm just going to write the 7 again. 7 over 2. And then times sine of the angle between them, which is angle y. And now we just simplify that, and then we'll have our final answer. So area equals, so the denominator will be 2 times 2 times 2, which is 8. And at the top, we'll have, 8. And at the top, we'll have 1 times, x times x is x squared. Root 3 times root 7 is root 21. And the sine y I'm going to put at the top as well. So there we have it. That is the area of our triangle. So these kind of questions, they can sometimes be a little tricky because we have to first find information in another triangle and then put it back in the one we're working with. So I think the best skill to practice for these kinds of questions is to be able to get a 2D triangle out of the 3D shape and work with that one separately. And even if it's a couple of different ones, just to work with all of them separately and then solve. Thanks for joining me for question 7, and we'll be back with question 8.